Hello my dear students, how are you all? Welcome back to Diksha Karnataka YouTube channel. I hope all of you are doing very good. Okay, so as you know, we have completed the integrals chapter. It was challenging. We have done all of it. We have done a revision also. We have done and we have written a mock on the integration as well. Okay, so that completes that particular chapter. Now moving on to a very new topic, which is area of integrals. Okay, I know the weightage is less. We can expect around 1 to 2 questions. Let's say 2 questions from this particular topic. Good for us. Why good for us, sir? Because we have put so much of our effort and we have given so much of our time for the previous chapter. Okay, then let's benefit from that. Okay, how can we do that, sir? So we have learned integrals in detail. We'll learn again some simpler concepts, few more simpler concepts in this particular chapter, and we'll make use of our previous learnings and get those 2 marks in our KCET examination. So no big deal, sir. Very easy, very interesting because of the previously learned concept for us. Okay, so let's make use of the our learnings, our time spent. Okay, so I hope you have prepared your formula sheets, as I have kept asking to you repeatedly in the previous sessions, that prepare formula sheet for especially for calculus, and then you prepare for all the topics as well, but for calculus you should have it, because you're going to make use of those formulas every session that you are with me. Okay, so in today's session we'll talk about very basics. Okay, starting from area under the curve, okay, and some important functions. Okay, we'll try to complete this particular chapter in 2 to 3 sessions. Okay, let's see, and we'll solve all the questions that is possible for us, that is important for us to solve, and to get prepared for these 2 questions coming in our KCET examination. All right, and we have to get those 2 questions right at all costs, because these are very important, very important and very easy. We don't have to worry that much about this questions coming from this particular topic. Okay, so I hope you are prepared. I hope you are ready. If you need to take a break right now, because once you start the video you should complete it in one go. Do not keep it, don't do half at a time. If you start, complete it right away. Okay, that's one way to that's a very good habit to have. Complete a task that you are taking in your hand. Okay, so if you need to take a break, have some water, come back, and then watch the entire session and solve all the questions with me, because the questions will not be that difficult. I'll give you tricks how to solve it. I'll give you tricks how to understand the questions in this particular chapter, and because that's very important. Okay, because working part is very less in this particular chapter. You don't have to do a lot of bigger integrations as we used to do previously. Today we'll talk about the tricks. How should we know the graphs? How should we know make use of the functions and the variables, and how to apply limits? Only that much, and you don't have to do a lot of working, so you can solve the questions with me only. You don't have to I don't think you need to pause the video also to give the solutions of the questions. If you understand the concepts, you will solve the questions within maybe in 15-20 seconds. It'll take you to solve the questions and get it done, and you'll get it right as well. Okay, so let's start with the session. Let's not waste any more time. Keep your pen and paper ready and solve the questions with me. Chaliye, moving on to the first thing which is coming up. What is it, sir? Area under the curve. Okay, very simple function, very simple function. Okay, y equals to fx. Okay, we have not taken the nature of the function, whether it is trigonometric or it's linear, doesn't matter. Any given function y equal to fx is there. Okay, so means a function is written in terms of the variable x. It can be a linear, it can be a quadratic function, does not matter. Okay, we have been asked to find the area under this particular. So you know that, right? Every function will have a curve, right? Linear function also has a curve. Sir, it's a straight line. Straight line is also a curve, bacha. Okay, circles will also, so quadratic functions. Okay, so any functions you see will have a curve nature, parabola, circles, okay, or ellipse, or whatever curves are there. Trigonometric function also has curves. So for any function that you have, they will have a curve. So area under the curve means that for that particular function was the area bounded by the region, okay, which includes the curve and certain boundaries. Okay, these boundaries are called as what? If you remember, limits of integration, upper limit and lower limit. Okay, these boundaries where the area is enclosed is called as limits of the integration. So this is my upper limit, this is my lower limit. X equals to a is my lower limit. We'll see how we use integration in this right now, and why we use integration, that also we will see. Okay, so first of all, understand the condition, what we are looking for. So we are looking to find the area enclosed by the curve and the boundaries assigned to us. They will assign the boundaries. Without assigning the boundaries, how can we know what is the fixed area, right? Excuse me. So in every question that they will give us after assigning the boundaries as well. Okay, means if this value a and b is not known, how will we find it? How will we find the area? Chaliye, let's read. Area of a region bounded by curve y equals to fx. Okay, and the x-axis the line x equals to a and x equals to b. See, boundary will be stated in the question. Boundary will be stated in the question, excuse me. Okay, so this is the function one side, other two sides are the line x equals to a and the line x equals to b. Have a look, please have a look. And one more thing they have written, x-axis, means this horizontal line, the x-axis is also, because if this is not there, no, then this area will keep increasing, right? Because if this limit is not there, it will go below the x-axis also. So that's why the boundary is x-axis as well. Okay, not necessarily, not in all the cases, but in this particular case they have given, they will always specify what is the boundary. Okay, so area of region where the curve is above the x-axis. Okay, let fx be the continuous function. Okay, means the function fx is given continuous in which interval? In the interval a to b, means from, so if you write the closed interval like this, the function is given continuous, then we can find the area using what? Integration. And how do we do that? So we draw a very small strip, rectangular strip. Okay, so is it rectangular? Think about it. If you make it smaller, okay, what will happen? You'll have a very thin strip, right? You'll have a very thin strip. So almost this width you see will be almost very small. You can't even measure it. That's small. And the thickness is taken as dx. The thickness of the strip is taken as dx. The length will vary from a to b. The length over here, please check over here. What is the length of the strip? If this black strip is moved to the line AB, what's the length of the strip, sir? It's a. Okay, and if it goes till all the way till x equals to b. Okay, so those are my limiting conditions for integration. A to b, both places are the same thing you've seen. Chaliye. So if I can divide this entire region in n number of strips, correct? No, will it be finite, sir? No, we can't define a finite number of strips that will be enclosed in this area. Okay, so if we start from this point A to B, we will have these strips, right? Keep going like this. You'll have these strips like this. Please have a look. So starting from here also, you'll have a strip over here. Okay, and it will go all the way to this also. So this will be my strip. Again, what is my thickness? Thickness is always dx, sir. Here also thickness is dx. Okay, very small thickness. Okay, so if you can take those strips and take their sum, then you'll end up with the area. Means this rectangular strip that you can see, okay, if you take the sum of all these rectangular strips and add all of them, you'll get what? Area enclosed in this region. Correct. So how do we take sum, sir? Since we learned this, integration is what? It's sum. Okay, so we can take the integration of the function fx. Why the function fx? Because what is the boundary over here? The function fx only. So if we can take the integration of what? Of the function fx, sir, with what variable? With x only. So I write fx dx. From where to where? The limiting conditions, the boundaries, sir. The boundaries are from a to b. Then we'll end up with what? We'll end up with area enclosed or area under curve what? Fx from limit where to where? From a to b. From a to b. Have a look. So the area bounded by the curve, x-axis, and the lines x equals to a and x equals to b is given by what? Integral of, see, I can write this fx as what? Simply y. No, why, sir? Because y is equals to fx is the given function that we have. So I can write it as simply y, or write it as fx dx, provided the limit is same, a to b. I hope this is simple. Okay, I hope you are able to make sense to what I said right now. This is very important. Okay, you should know what it is actually the meaning of area under the curve and why do we use integration. We use integration because we have to take the sum of all these vertical strips. Please check, what is this? Vertical rectangular strip, sir. Okay, when we change the function in the coming slide, we'll see we'll also get the condition where the strips are horizontal. So I hope this is clear. Please have a look. I hope everything is visible on the screen. Okay, so moving on, please see over here. Now in this case we have horizontal strip. Why? How come, sir? Because if you check the limits, the boundary starts from y equals to a to y equals to b, y equals to a to y equals to b. So in this case the function is rewritten in the form of x equals to fy. Now they might give you the function already in the form of y, or you have to find the inverse and find it. It will not be that difficult to find. You can just find the subject, you can change the subject from there and find the inverse, find the function in terms of y there and make x the subject, alright, and then you will take the integration for f of y. So this will become what? Same thing, f of y. Now what will this variable be? Dy. Variable will be dy. How come? Because the boundary is given for y. From where to where, bacha? From a to b. From a to b. Please have a look. Y equals to a to y equals to b. Okay. How come this, sir? Because the strips you check here, the rectangular strips are horizontal in nature. Okay. And then you have to find the area of this enclosed figure. Okay. You have to include all these strips here, bacha. All these strips you have to include. Okay, over here. So you check this, all these horizontal strips, you have to take the sum of all these strips area. How do you find this area? Okay, so it will be a length into breadth because it's rectangular strips, no? So it's not rectangular, it's a curved surface. But if you take this length, this thickness to be very, very small, what is that thickness? Dy. Thickness is dy all the places. Okay, it will become rectangle only. Okay, chaliye. Same concept, just across, just the strip is changed from vertical to horizontal. Okay, moving on. Area of region where curve is below the x-axis. Okay, no problem, sir. We'll use the same concept. We know one thing for sure. What is it? Area is always positive. We don't have a negative area. We don't say minus 25 meters square. We don't say that. Can an area of paper has negative value? No. Can an area of anything, a surface or wall can have a negative value? Have you ever seen? You solved questions on it, right? When you were in lower grades, in grade 10, did you solve questions on volume surface area? Yes. Did you get a negative area? Of course not. So area will not be negative. So what are you gonna do? Follow the integration, whether it is vertical or horizontal, the way we have learned in the previous two sessions, in the previous two slides, forgive me. So you find that integration for that particular function. See, it's fx here. So what are you going to write? You're going to write this as simply fx dx. Limits you will take as it is. What is the limit here, bacha? A to b. A to b. But the result has to be positive, so take a modulus. Wherever it is negative, wherever the area is resulting to be negative value, take a modulus function. This is going to be my area under curve. Okay, area under the curve. Okay, just take the modulus value. Same thing is written over here also. Okay, shall I move on from here? Okay, come on. Now, what it is? There is a combination of both positive and means both above and below. Means some part of the curve, same curve. You'll see. I have taken example like this. Okay, some part of the same curve is on the positive side of the x-axis. Means So positive side on the y-axis actually. So check here. This value of y is positive. Over here it's negative. What are you gonna do then? So either you can take modulus on both of the cases, or if you know which is positive. Because let's say you don't know where is positive, okay? You're not able to draw the graph. Then what are you going to do? Take modulus for all the intervals. So what are you going to do? Check here. So we are able to understand that from A to C, the area for the same curve is coming as positive. So see, the limit A to B has split into what? A to C and C to B. How come, sir? The property of definite integral. Right, I can break the limit from more than one way, right? Like this A to C, C to B, I can break it more than one time also if required. Okay, so A to C, C to B. A to C is positive. If you want, you can take a modulus over here. If you don't want, just keep it as it is, and you'll get a positive result over here. How come? What about this, sir? It will be negative value. That's why modulus will make the result to be positive, and that will be your answer. Okay, check here. So why there's a minus sign written here, sir? Because bacha, this fx is gonna be coming as negative value. This area will come as negative. So to make it positive, what are you gonna do? You have to include a minus sign. I'll repeat myself. The result of this integration will be a negative value. Okay. To make that function to be positive, okay, you have to include a minus sign. Okay, that's why minus fx. So modulus over here will open with a minus sign. That's why minus fx. Over here with a plus sign. That's why simply plus fx. Don't get confused. Okay, I have discussed this multiple times in my sessions, other sessions. Chaliye. So f of x is positive because function is positive over here negative. So opening with a minus sign. To make it positive, negative and negative will make positive. That's why minus fx dx. Okay, limits will be as it is. A to c, c to b. A to c, c to b. Simple enough. All right. I have taken a question on this case. We'll see how we solve it. Moving on. I hope this is visible, right? Moving on. Area of the region bounded by a curve and a line. okay, a curve in the line. Now we have to check whether the curve is, you know, above or line is above. We have to see. So that will depend upon question to question. I've taken a few cases over here. I'll show you as well. So let's see. In order to find the area of the region bounded by a line and a circle, okay, means there are different cases present here. First case is what, bacha? A line and a circle, okay, a line and a parabola, okay, a line and an ellipse, okay. We follow these following steps, okay. First one, step 1, draw the rough sketch. This is very important, okay. Sometimes what happens, no, just by looking at the question you miss some critical points. So but if you draw the sketch, okay, if you draw the sketch, then question becomes simpler and there's least chance of making a mistake. If you have the sketch in your mind, then you'll, you know, probability is that you'll not make any mistake in that particular answer or solution. Chaliye. So draw a rough sketch of a given curve and identify the required region. What is the meaning of required region? Okay, means where they are talking about. So you should know. Let's say I am looking to find this area. Where, sir? Only this much part, or this is my required region. Okay, so once you draw the curve, no, you'll get to know what's my required region to find the area for. Step 2, find the intersecting points. How come, sir? Why do we find that, sir? To find the upper and lower limits. Upper and, so this is how many points of intersection are there? One is here, so 2 points are there. Point number 1, intersection point number 2. So I have to find the point, the coordinate of these 2 points. How will you do that? By solving the equations of the curve and the straight line. Okay, you'll see I've taken an example of that. I'll show you in the coming slides. How do we find the coordinate of these 2 points of intersection of the curve, whether it is circle, ellipse or parabola with the line. Okay, very simple, not that difficult. Okay, so find the intersecting point or the points of a curve and the line. Step number 3, draw perpendicular lines from the intersecting point. So like this, if you remember, we have drawn in the previous cases. How come, sir? To find the limits. To find the limits, my x value will be this value, and lower limit and upper limit of this will be this x value. Okay, so and then I can enclose this area from here to here I'm looking for. Okay, okay. Intersecting points of the line and curve to x-axis, okay, or y-axis. If the function is, let's say, defined like this, I want to find, let's say function is like this, okay, then I might have to use a function like this. I want to use these 2 limits. I want to use y limits, okay. Then I'll draw the line from the point of intersection to the y-axis. In this case I've drawn to the x-axis, okay. X-axis and y-axis, my choice. I can draw based upon the question which is given to us, okay, not a problem. Okay, now if these perpendicular line divide the region into 2 or more parts, then take 2 or more vertical strips or horizontal strips. Are you able to understand this statement? I'll read again. If these perpendiculars that you have drawn, see over here I have only one part, but if after drawing this you get more than one part, you get 2 part or more than 2 part, okay, then in this case what will happen? You'll have to identify, more than once you have to do the integration. You have to do integration more than once. We'll see that. So if these lines divide the region into 2 or more parts, then take 2 or more vertical strips or horizontal strips. Horizontal strip in the case where function is integration is, this is the case where dy you are taking for the integration, and how vertical means dx. I have shown you, right? Correct, no? Do you remember this? The question that we took, the function was like this. From here to here we integrated, okay? This was the strip. This is the strip, right? This is my vertical strip. So if you're getting, let's say, more than one region like this, okay, then you'll have to take more than one vertical strips, okay? Please have a look. So if you're getting, if this perpendicular divides the region into 2 or more, check here. How many regions are there right now? These strips, these vertical lines, perpendicular lines you draw from the curve to x-axis, it has given how many regions? This whole thing is only one region, no? Only one region. If you have more than one, if you have more than one, in that particular case, what will happen? You have to draw more than one strip and do the integration more than once, okay? So this is the case where the strip is vertical. We're gonna take this as dx, okay? And what about horizontal strips? So if you see over here, you're gonna get, if you have the graph like, let's say like this, and then you have to consider, let's say, the limits like this, the point of intersection is like this. Let me show you an actual case. Okay, I'll try to draw a graph where a line and a curve is required. So if I draw it like this, let's say, okay, and the curve is, let's say, like this, okay, then my strips is not accurate actually, so let me redraw the line. Give me 1 second, just a second. I'll try to give you a better figure so that you're able to understand this. Okay, chaliye. So if you see this, and if I draw the strips perpendicular to x-axis, so perpendicular is drawn on the y-axis over here, okay, I don't have to. How many regions are there? Only one region. This is a case where strip will be, what is going to be? Is going to be horizontal strip. So again, I have to take what? Dy. I have to take what? Dy. Okay. So if you get more than one, you have to draw more than one strips. The reason is only single over here. I don't have two regions. I have only one region. So I'll take only one strip. But if it is more than one region, which is two or more, then I have to take what? I have to take what? If there is two or more region, then I have to take what? Two or more horizontal or vertical strips based upon the condition. I hope this is visible. Please have a look. Okay. Chali. Moving on. Again, these are very rough figures. Okay, these are very rough figures. We'll see actual figures and actual questions in the graph and the important functions when we are dealing with it. Okay. Step number 4. Now we will find the area of region for one vertical or horizontal strip, whatever is given in the condition. Okay. If it is two vertical or horizontal strip, we have to do it separately. Okay. Let's see. So if it is one, we'll see whether it is horizontal or vertical. Horizontal means dx will be there. Okay. So this is vertical strip, right? Means dx will be there, same thing I explained right now. And for horizontal, what we'll have? We'll have dy. Do the integration, find the limit value from a to b. Okay, the values will come for that. Right now, just standard value taken as boundary is a to b. Okay, so x will be y. Sir, how it is x, sir? Because if you check here, this x will be written like this, bacha. This x is nothing but x equals to function of y, and over here this y is nothing but y equals to function of x. Okay, so this will become basically fx dx, and this is what? Fy dy, Fy dy. Okay, horizontal means dy. Vertical strip, if you are getting, you'll have dx in it. More than one, if you have, means for two vertical strips, okay, or horizontal strips, you're gonna use what? 2 times. So the function will be changed, right? The function will be different. So y1 dx, again y2 dx. Okay, the limit is changing. We saw the case right now, a to c and c to b. A to c, because in a to c you'll use the function y1, and for c to b you'll use the function y2. Same goes in the case of horizontal strip also. So it will be c to e, just a case, x1 you'll use, and e to d you're going to use x2. Again, x2 will be what? My x2 is going to be f of y. F of y. Same goes with x1 also. Okay, so if you have two or more vertical or horizontal strip, you have to use the integration multiple times. You know, if it is two times of if the region is 2, then you have to use 2 times, 3 then you have to use 3 times, and so on, like that. Okay, so based upon the number of strips, number of region that you have, you'll have to consider those strips, vertical, horizontal, and find the integration like this. Again, remember, vertical strip means dx will come, horizontal strip means dy will come. Please have a look. I hope this is visible. Moving on. Okay, now few note, okay, about the symmetry of the curve. If the equation, again I think I've taken a question on this, I'll show you later. If the equation of the curve contains only even powers of x, then the curve is symmetric about y-axis. Example, sir, this, please check y equals to, okay, even powers of x, right? Or x square equals to y, 4ay or ay, like this. I can write like this, or I can write like x square equals to ay, something like that. Okay, if you check the curve, if it has equation contains what? Even power of x, then curve is symmetric about y-axis. Opposite, if it is having even powers of y, in that case is going to be symmetrical about x-axis. Okay, if the equation of this curve remains unchanged, where x and y is replaced, okay, means if you replace y minus x and y by minus y, okay, y by minus y, have a look. If you change if you replace x by minus x and y by minus y, okay, and the curve remains unchanged, it means that the two curves will be symmetric, the curve will be symmetric about opposite quadrant. Okay, means first to third and second to fourth, first to third and second to fourth. Okay, if by changing x to minus x and y to minus y, the curve remains same, the curve remains unchanged. Okay, if the last one, if the equation of the curve remains unchanged where x and y interchange, means if you take instead of x you take it as y, or instead of y you take it as x, the curve remains unchanged, it means they are symmetric about what line? Y equal to x line. Okay, means they are invertible function actually, so symmetric about y equal to x line. Okay, if the equation of the curve remains unchanged where x and y are interchanged, then the curve is symmetrical about the line y equal to x axis, so they are invertible function. Okay, all right, moving on. Now some important curves, we'll see how we can find the point of intersections, what are the curves, how can we find the area, we'll see all these conditions. First one, curve number one is, we are looking to find the area. Ultimate goal is what? Looking to find the area from where to where y, this value, if you check here, this value y over here lies between what? The lines, this line, this is a straight line, no? How come like a straight line, sir? It's a linear function. Mx is a linear function, right? Mx, x power 1 is there, so linear function. Between the linear function and the ax square, what is this? A quadratic function. Ax square means quadratic function. What type of curve is going to be what, sir? It's going to be a parabola. Okay, so if what type of parabola is this? Vertical. Okay, like this. Okay, so they are looking to find the area from where to where? Between the straight line, means lesser than the straight line, or below the straight line and above the parabola. So please check. I'll draw this figure for you if that is not visible. So basically we're talking about this region. The parabola, but above the parabola, area bounded by above parabola and below the line. So like this. Okay, so this is what line? Y equals to mx line, and what is this curve? This is y equals to ax square curve. This is y equals to a x square curve. Okay, so below this thing, what is my region? And above the parabola, my region is this bacha. This is my region. So how would I find this area? How would I find this area? Okay, so what we're gonna do, first thing is what? If you remember the steps, first thing is you have to draw a rough sketch. We knew this now. How, sir? Y equal to mx is straight line, sir, passing through origin. How come, sir? Put x as 0. What is my y value? X is 0, y value is again 0. Passing through a straight line, pakka. Okay, so y equal to mx line will come like this. What about parabola? Sir, this is standard function. Y equal to x square is standard function like this. No problem there. Okay, so vertical up parabola. Why, sir? Because if a is taken as positive, vertical up. If you take a as negative, will become vertical or concave down. No problem. Okay, so one critical point we already know, the origin 0 to 0. Why critical point 0 to 0? Because we are looking for what? Point of intersection of the curves and the line. So curve and line intersection is 0, 0. Other one is this value. This is unknown. This is unknown value. We have to find that. So sir, how will we find that? How will we find that value, sir? We'll take the help of the given two equations of the curve and straight line. Let's see. So what is the y value from here? Please check. Mx. Whatever is the y value will satisfy this also, because they are having a common point. So I can write this y as, from here, mx equals to ax square. I can cancel one of the x. What I get? I get m by a equals to x. Correct? Because there is one x left over here, and I can take a on the denominator like this, m by a. Now substitute this x in terms of in place of y, sorry, in over here, and find the y value. So I get y equals to a x square. What is x? M square by a square. M square by a square. This and this cancels. What is my y value? Y value is m square by a. So this is the way we find our point of intersection. Why we do that? We'll see that now as well. Point, what is this point? M by a and m square by a. M by a, comma, m square by a. Now once you find this point, what's the next step? There's no need of perpendicular over here. We have to do it for this part. What's this point? Simply, sir, m by a. We'll write only the x coordinate, no need of other thing. Okay, please check. The coordinate is m by a and m square by a. Okay, chali. Now the integration part, what are you gonna do? the lines function minus parabola function. Why minus parabola, sir? Because parabola is down. Please check the limit condition. Okay, please check the limiting condition over here. More than ax square is there, right? More than x square. So means what is the highest point? Mx means y function is less than mx but more than ax square. That's why line minus parabola we have taken. If it is ulta, we will not have the condition only. Okay, chali. So 0 to m by a, why, sir? The limits. Please check. 0 is my x value over here. This is my x value over here. So my x value over here is 0 and over here is x equals to m by a. This becomes my boundaries or the limits, upper limit and lower limit. So 0 to m by ma. So if I'm writing integration like this, what I'm going to get? Please check. 0 to ma. Okay. The area, for the area part, I have to take the function. So mx minus ax square. How come mx, sir? For the line, and ax square for the parabola. And with the dx, we have to take the integration. Once you do the integration, you're going to get the result as 1 by 6 m square by a square. What's the answer? 1 by 6 m square by a square. Okay, very simple. Interesting. So what is the important point to know here? This you don't have to remember. If you do, very good. You can use it directly in the questions. But what is the most important point to remember here? How to form the curve. Okay. What are the properties that we have to find out from the curve? So we have to find out the point of intersections. Okay. To know the upper and lower limit, and we have to know which region we are talking about. Okay. So region is the shaded part in the green color. Okay. So I hope this is visible. Please have a look. Okay, moving to function number 2. Same thing, but instead of y equals to mx, in this case we are taking y equals to mod mx. Okay, mod mx means what? There is no negative value now present. So if you check here, this line which was there like this is not present anymore. It has gone up. It has gone up like this. It has gone up like this, because we have taken what? We have taken mod, sir. We have taken mod, sir. That's why the negative part of y equals to mx line has gone up. Okay. Same thing will happen. Again, same approach will apply. Okay. So how do we find this area, sir? So if you remember, if you see this here, what's the square of this thing? Symmetric is about what? Check the curve. Check the curve. What curve is this, bacha? This curve is y equals to ax square. We learned about symmetry right now. So why symmetry is important in this chapter? Because we don't have to find the area twice. If you find one area, since it is symmetric, you can just multiply it with 2. Okay, that's why symmetric is important. So x square means even power of x is there. Even power of x means what? Please have a look. Symmetric about y axis will be given. Even power of x symmetric about y axis. For that reason I can just find the area of the right hand side and then multiply that with 2. Okay, so that's what is done here. We got this value mx minus ax square. Please have a look, as 1 by 6 m square by a square. You multiply that with 2, so this 2 will cancel this 6 with 3, so you're gonna get what? 1 by 3. I'll show you over here. Please have a look. Okay, so if you multiply this whole thing by 2, 1 by 6 m square by a square, what are you gonna get? This 2 will cancel this, no? This will become what? 1 by 3, right? Same thing written over here. 1 by 3 m square by a square. Okay, and how to find that previous one? We have seen it over here. How to find the point of intersection and everything, we have seen it over here. All right. Okay, please understand this. What's the point? The point is from where to where, bacha? What is by point A? Minus m by a and m square by a. Okay, what is point B? We found this value m by a and m square by a. If we have to do the integration, we have to do from where to where? From minus m by a to m by a. How come, sir? Please check. There shouldn't be any confusion. There shouldn't be any confusion, sir. Drop the lines like this, no? Okay, what is this? Minus m by a, and what is this point? M by a. But I can take again property of definite integral over here, sir. Yes, I can write this as 0 times 0 to a, 0 to simply m by a with multiplication of 2. Okay, alright, simply 0 to m by a multiplied 2 times. How? We just saw it here. Okay, this is incorrect, the spelling. Please change it, A-R-E-A. Okay, the solve for this function. nothing much is there, right? Since modulus is there, so negative part has gone up, okay, and rest we have just multiplied with 2 to get the, because of the symmetry present in this case. And how to find this area we learned in the previous particular function. Okay, moving on. The question number 3, in this case what you have taken, the power of 2 is on y. So what is that? What type of parabola is this? Horizontal parabola like this. So since it is positive, it is across right side, so a right horizontal parabola, okay, concave towards right side. All right, now in this particular case, if you see here, what function has been taken, bacha? The function remains same, y equals to mx is the line. But check now, in this case, previous case the line was above, check here, y equal to mx was above the parabola, but in this particular case line is below the parabola curve. Okay, so if you take that, if you take there in the shaded area part, okay, check here. So now we will take what first to find this area? The limit we will take. How to find that we'll see that right now, but for now you just see this. We'll take what to find this area? We'll take what? Integration limits we'll see. We'll take first parabola, okay, and then we'll take what? Minus line. So in the previous case the line was coming first and parabola is coming next, but in this case parabola minus line is there. Okay, the limits. What about limits, sir? So one point is the very simple, 0, 0. The one of the boundary is 0. So 0 is there, no problem about that. What about other point? How do you find this 4a by m square, sir? How do we find this coordinate, sir? 4a by m square. Okay, if it is not visible, that same point is written over here. Please check. 4a by m square. Okay, how do we find this value, sir? What we're going to do, put this mx in place of y. Okay, what is the given condition? Y square equals to 4ax. In place of y we're going to put mx, so we'll put it as mx the whole square equals to 4ax. What are we going to get? M square x square equals to 4ax. Cancel this x with this. What I'm going to get? X equals to 4a by m square. 4a by m square. Now to find the value of y, put in the equation. Y equals to mx is there. So m, what is x value? 4a by m square. 1 m will cancel this. What I'm going to get? 4a by m. My y value is 4a by m, bacha. 4a by m. Same thing is here. X is 4a by m square and 4a by m is my y value. Okay, for the coordinate of the point of intersection A. Okay, now we'll take what? The limit will be what? Only for x, right? So 0 to 4a by m square. 4a by m square. No problem there. Okay, chaliye. Okay, 1 second. This is area. Area is given by 8a by 3m cube for this part. Okay, what about this part? What is the change over here? The change is same, sir. Just modulus is present here now. Over here we didn't have any modulus. Y equal to mx was there, but over here I have y equal to mod mx. But doesn't matter in this particular case. How come, sir? Mod means what? This part, this line you see here will go up like this, correct? But even if it goes up, does not matter because there's no curve on that side. This curve is not present on this side. So how will you find the area under the curve? Correct, no? Is there a parabolic curve on the left hand side of the y-axis? No, sir. Then the area will remain same under the curve. Okay, we don't have, so whether you take y equal to mod x or mx, simply mx, mod mx or simply mx, the answer is same. Check here, 8a square upon 3m cube. How will you get this? Simply using this formula with this limit. This is my area under the curve. This is my area under the curve. Please apply this and get the answer. Okay, please apply and get this answer. Okay, 8 square upon 3m cube. How are you going to get? What is the parabola equation over here, sir? 4ax, okay, minus line equation, simply mx. 4ax minus mx you're going to do in the limit 0 to 4a upon m square. Can you do that? Yes. All right, chaliye. Okay, so if you want I can write it for you. You have to find the final answer, but I'll just write it for you just to help you with the doubt if you are having it, sir. What is the actual integral over here? Parabola is what? 4ax. So write it here, 4ax minus mx. Okay, so it's going to be like this actually, bacha, root 4x, because y I need know is y square equals to 4x. I have to take the root over here. So root of 4ax will come. Please integrate this. Okay, 4a will, the constant will come out and will become x power 3 by 2. This will be x square by 2. Okay, solve it. X square power 3 by 2 upon 3 by 2. The integration will come. You know how to integrate this. Limits you apply, you get the result as a square upon 3m cube. Okay, I hope this is clear. Okay, shall we move on? Okay, chaliye. In the first problem, okay, we'll see similar question is there. We'll see how we integrate this part. So calculate the area under the curve y equals to 2 root x included between the lines x equals to 0 and x equals to 1. Great, sir. First, what is the first step? Try to identify, if possible, try to identify and draw a rough sketch of the given function. So what is this function? Y equal to 2 root x. Looks difficult right now. But if I do and make some change over here, please have a look. Square on both sides. So what I have right now is y equals to 2 root x. If I square it on both sides, y square equals to 4x. Yes, 4x. Okay. Excuse me. Square on y means symmetric about x-axis, sir. Symmetric about x-axis, sir. Okay. Now the limiting condition x equal to 0 is which line? Sir, simply y-axis. X equal to 0 is simply y-axis. What about x equal to 1 line? So something like this. Okay, sir. If you are integrating this, sir, then don't we have to do both the areas, sir, both up and down? Do we have to do this, bacha? No, sir. Why? Because they have given only 2 root x. Only 2 root x. Because if you take root of this value from here, you're going to get this as 2 root x and you're going to get this as minus 2 root x. Have they asked to find the area for this curve minus 2 root x? They have not, bacha. So we will not consider what, sir? This particular region. We will not consider. Only will consider which region, bacha? Will consider only this region. Okay, so we'll integrate this function. What happens? No, sir, since you said to draw the graph, I got the graph and I saw 2 parts in this bounded region. From 0 to 1, I have 2 parts in the parabola. Integrate both of them, sir. But they have not asked for the entire parabola, bacha. They have asked only for 2 root x. If they would have given this value, y is equal to 4x, then we have to take both the condition. But they have not given that. They have given y equal to 2 root x. Now for that reason, I have to take only the positive part. Okay, we'll see. So how I'm going to do this? You know this. So 0 to, this is 0, right? 0 to 1 integration. This is my area. From where to where, bacha? Tell me. From where to where? For which function? 2 root x. Okay, dx. Take 2 outside. Integrate root x. You're gonna get what? X power 3 by 2 upon 3 by 2. From where to where? 0 to 1. Okay. 2 will come up. Will become 4 by 3. Check here. 3 by 2 is there, no? The constant I can take it outside. 2 is in the denominator, will go and become 2 in the numerator. 2 into 2 will become 4 by 3. What's the result that I have left from after taking the constant outside? 0 to 1. Okay. What is my answer? 4 by 3. Please check. At 1 it will be 1 power 3 by 2 and minus lower limit 0 power 3 by 2. What's the answer? Simply 1. So 4 by 3 times of 1. What's my answer? 4 by 3. Area is there. Is there a unit given? No. What I'm going to write? Simply square units. So 4 by 3 square units. This is not looking like A. Let me rewrite this part. This is 4 by 3. This is 4 by 3. So simple question. Very simple. Why not we use the negative part? Because the question is not mentioning or giving any hint about negative part, only positive they have asked. Okay, shall we move on to the next question? Okay, chaliye. Find the area of the quadrilateral formed by the lines. Okay, so we have how many lines? 1, 2, 3, 4. So let me draw the curve first. I'll try to draw the curve over here only. So my coordinate axis, x here, y here. First, so look at here, 0, 2, 4. These are simple curves. I don't have to worry about that because they are straight lines parallel to x or y axis. What about this one? Let's check this first. So if I take x equals to 0, I'm going to get y value as 3. So my one of the point is like this. One of the point is like this. Okay. 0, 3. How come, sir? Put x as 0, bacha, here. This whole thing will become 0 plus 3 will be simply 3. So y equal to 3. Y equal to 3. So x is 0, y equal to 3. Okay. Now, if I put x equals to, let's say I put x equals to 2. What is the value? X equal to 2 value is going to be 4 plus 3, 7. So somewhere over here. Okay. So the curve will actually go like this. Correct, no? Because for 2, if I put x equal to 2, somewhere over here, let's say. X equals to 2 I'm putting. Okay. In this curve. So 2 times 2 will be what, bacha? 4. 4 plus 3 is going to be what? So 7, sir. This is 7 point. This point 7 is there. Okay. Let me rewrite this. This value is what, bacha? This is 7. Okay. What about 4? Put 4. 4 times 2 is 8. 8 plus 3 is 11. Somewhere over here. What is this? X equals to 4 line. Correct, no? How much is that going to be? Tell me. Simply, sir, 11. Simply, sir, 11. Okay. Simply, sir, 11. Okay. All right. And y equal to 0. Very simple, x-axis, no? What's the curve of this? What's the equation of this x-axis? Y equal to 0, sir. So they are talking about which region? Please understand. They're talking about this region, bacha. Okay? This region, sir. This region, sir. They're talking about this region. How come, sir? What is this line? Y equals to 2x plus 3. X plus 2, x equals to 2 and x equals to 4 is the boundary, and one more is y equal to 0. And what is this line? Y equal to 0. Simply x-axis. Okay? Simply x-axis. Alright. So we have to find this area. Okay? So if I can integrate this function 2x plus 3 from where to where? From 2 to 4, my job is done. From 2 to 4, my job is done or not? Yes? So if I write this integration like this, I'll get this area as integration of what? 2x plus 3 from where to where? From 2 to 4. With what variable? With x. My job is done. Please check 2 to 4 because boundaries are 2 to 4. Correct? Okay. Moving on. Let's do this integration. I'm going to get what? So, it'll become 2x square by 2 plus 3x by 3x plus 3x from where to where? 2 to 4. Please check. 2 and 2 will cancel. What I have now? X square plus 3x from 2 to 4. Okay. Put here 4. You're gonna get what? 4 square is what? 16, bacha. Okay. Plus 12. Yes or no? Please check. I'm putting only upper limit. So 4 square is 16. 4 is 12. Okay. What about lower limit? 2 square is 4 and 2 power into 3. So it's going to be simply 6. Okay. Please check. So 28 minus 10. How much is that? 18. What is the unit? We don't know. So right now we'll write it as square units. Square unit. What is my answer? 18 square units. Option number B. Okay. Simple question. Very simple. Just you have to draw the graph to understand the curve. Okay. Chaliye. I hope this is visible. Moving on to the question number 3. Okay. Find the area of the triangle formed by the straight lines y equal to 2x equal to 0. Okay, by integration. So basically they're saying that if you draw this curve, you're gonna get an integral, triangle somewhere. Try to find the area enclosed by this triangle. Okay, by these straight lines. Let's draw the coordinate axis first. This is my x-axis, my y-axis. Curves are what? Y equal to 2x. This is a curve passing through origin but inclined towards y more. So like this. Okay. This curve is y equal to 2x. The points x equal to 0. X equal to 0 is this line only, no? Correct, right? X equal to 0 is y-axis. Y equal to 2. Somewhere like this. This is my y equal to 2. Which area is we are talking about, bacha? This area, sir. This area, sir. Correct, no? Check the triangle. This is what the triangle is. Y equal to 2 is line like this. This is my y-axis, x equal to 0 line and the curve. So if I integrate this function, what function, bacha? Y equal to 2x. Sir, over here if you draw, no, you'll get strips to be horizontal, sir. You'll get horizontal strip, sir. You're gonna get, sir, horizontal strip. Then how come you're taking y equal to 2x? I will change it. I'll change the subject. I can write this as, you'll see how will I change. So y equal to 2x can be written again what? As x equals to y by 2. X equals to y. So write this function to be x equals to y by 2. Now I can integrate this. I can write this as integral of what? Y by 2 d by, what's the limit? What's the limit? From 0 to what? 2. Please check. What is the y value over here? 0, 0, right? So my y coordinate is what? 0. And what is the y coordinate over here? 2. So I can write this as, again, 0 to 2, and this will be what? Area of the triangle. It will be area of the triangle, sir. Okay, please integrate this. Here I get what? The 1 by 2 is a constant, taking it outside. I get what? Y square by 2, from where to where? 0 to 2. Okay, take this 2 common again. 1 by 4 I'm gonna get y square from 0 to 2. Put the limits. 2 square going to be 4 minus 0. How much is the answer? 1 by 4 into 4. Simply 1. What is the unit? Square unit. Square unit. Have a look. Option number A. Simple enough. Have a look. Okay, we had to draw the triangle. First step was to know the curve, then we have to draw the points of intersection, we already know, and then drop the, drop the perpendicular lines from the curve to the y-axis, because this is easier to do that way. Okay, otherwise we have to find this point. Okay, we can do that. We have to find this point. That's all. If you want this to be integrated like this, if you want this integration with respect to dx, no problem, just drop it over here. But again, we don't want that area, no. We want this area, right? We want this area. So that's why we are not using this part. What we have to do then in that case, find this area, take the full area, then subtract this shaded area. There's no point in that. So this is simple. So simply change this function to be x as subject, get the function in as y by 2, take the integration with dy, because strip is horizontal, so strip is horizontal. Okay, so I hope this is visible and you understood this as well. Chali, moving on. Question number 4. Area of the region bounded between the line x equal to 2 and the parabola y square equals to 8x. Y square equal to 8x. Have a look. So first step is to do what? To draw the curve. What type of parabola is this? Square on or even power of y, means symmetric about x-axis. And x equal to 2 means what, bacha? Line like this. Okay. Area of the region bounded by these two means what? What is the area? What's the area, sir? This is the area. Both of them. Okay. But do we need to do both the areas? No, sir. Actually, what we can do, no? We can find one of the area, only this part, okay, and then find this area A, and then take what? Take 2A, double it, then you're gonna get what? You're gonna get the entire area. Now how are you gonna write the area for this part? Okay, what's the curve over here? So you have to take y value as root of 8x, yes or no? Yes. So this is what value? This is y equals to root 8x. What is this curve? Y equals to minus root 8x. We don't need to do this. We don't need to do for this part. Only the positive we're gonna do, and take the limit from where to where? 0 to what? 2. 0 to 2, and then whatever the result I get, multiplied with 2. Okay. So my area A will look like this, twice of integration from 0 to 2 root 8x dx. Please check. Anything I missed? Limit is correct. 0 to 2. Let's do the integration. So I get what? 2 times is outside. The constant is root 8, right? So what is root 8? 2 root 2. Root 4 is 2, and root 8 is what? 2 root 2. So take 2 root 2 outside. Okay. Integration of root x. How much is that? Integration of root x is x power 3 by 2. X power 3 by 2 divided by 3 by 2. Okay. From where to where? 0 to 2. 0 to 2. Okay. So 4 root 2. Okay. Now multiply this with 2 constant outs up, and this 3 will come below. What's the variable left now? Now we'll put the limits. We'll put the limit. So what we're getting? We're getting 8 root 2 by 3 outside as constant. And what is this? Please check. 2 you put. 2 power 3 by 2 minus 0. How come 0 says 0 power anything is 0 only, that's why. So what I'm getting, please check. I'm getting this answer as, if I do it over here, so I'm getting my area so far, my area as, what bacha? 8 root 2 by 3, 8 root 2 by 3, and 2 power 3 root 2 means what? So 2 power 3 by 2 means what? So 2 power 3 by 2 means simply again 2 root 2, correct, no? 2 power, 2 to the power 1 by 2 means what? Root 2. Then power 3 means root 2 into root 2 into root 2. So root 2 into root 2 will become 2, and then 1 root 2 is left like this, so 2 root 2. Please multiply. So 16 into 2 by 3. So what is my area? Area is 32 by 3. This is my area, right? I've already taken this 2 times in the beginning only, so I don't have to multiply 2 again. What is my answer? Answer is 32 by 3, option number B. Okay, that's why the curve becomes very important. I don't have to do again for the negative side. I can do it, no problem there. But why do that? Find this area. Since square is on or the power even is on y, symmetric about x-axis, we can say that clearly. Find this small area, multiply that with 2 to get my required result, which is 32 by 3. I hope this is visible. Please have a look. Okay. If you are having any doubt, I find this chapter is very simple, but if you think I'm going faster, if you have any doubt, please give me your queries in the comment section. I'll try to answer your doubts or your solutions. Okay, so find the area of the region bounded by y square equals to 4x. Okay, x equals to 1, x equals to 4, and the x-axis in the first quadrant. Okay, so what I'm going to do, I'll draw everything, I'll give you the figure, then you have to solve the question from your side and give me the answer. Okay, I'll give you the answer also, but you have to solve from your side. So let's see, again, square root on y means symmetric about x-axis. X equals to 1, so from over here, 4 over here, okay, 4 over here, 1 over here, and the x-axis means I'll take what? Only the positive part. I don't have to take which? Negative side. They have given what? X-axis only. This is my required area A. So to find A, what are you going to do? To find A, integrate from where to where? 1 to 4. From 1 to 4. The limits are given. 1 to 4. What is the function? So simply root 4 x dx. Please solve this. Okay, solve this. Solve and comment your answer. Comment your answer. I think the answer should be what? 28 by 3. Please have a look. Okay, what is the answer? Answer is 28 by 3. Okay, please have a look. Okay, very simple. Moving on, sir. Question number 5 is done. Question number 6. Find the area of the region bounded by the parabola y square equal to 4ax. Its axis means what? X-axis or y-axis, like that, and two coordinates are x equal to a and x equals to 2a. Okay, we'll see. Again, what are you going to do? So here we don't have a value given. We have to find in terms of variable only. So first step is what? What's my first step? To draw the curve. Curve will be like this, bacha. That's my curve. Okay, parabola. X equals to a will be somewhere here, and this is my x equals to 2a. Okay, and what? So from where to where? This and x-axis is required. So only we're gonna take which part? Only this part we're gonna take. Okay, only this part we're gonna take. So what will the area look like if this is my integration A? For the area under the curve is A. So my area A will look like what, bacha? A to 2A. Integration from A to 2A. I have to take root of this because y square is 4x means what? Y will be equal to plus minus 2 root A root x. Yes or no? 2 root A root x. Since we are talking about only this part, we have to take what? Positive. So I'll take this as 2 root a root x dx. Take the constant outside. So 2 root a is outside. Okay. Integral of what? Root x dx. From where to where? From a to 2a. From a to 2a. Simple enough. Very simple. Right? Any doubt in this? I don't think there should be. So they're saying this in the question, and it's axis. It means that actually it's going to be what? Axis both, right? But y is not considered over here because it's after y axis. Okay. So about x, if we're taking the limiting condition, about x, above x we have to take. Okay. So only this area is my relevant part. Okay. So that's why I have to integrate this curve. Okay, from limit a to 2a like this. Chaliye, let's do the integration now. So 2 root a, the constant part, this is going to be what, bacha? X power 3 by 2 from where to where? A to 2a. A to 2a. Now have a look. So my area will be given by what, bacha? 2 root a, the constant outside. Okay, I'll write this thing as it is, 3 by 2. Achha, I forgot to write that. Upon 3 by 2. Upon 3 by 2 is there. A to 2a. So 2 root a, I'll take the constant outside. I'm going to get this as 1 second. So I'm going to get this as 2 root a, multiply this 2 over here, 3 will come in denominator. Okay, write this with 2a to the power 3 by 2, whole thing is there, minus for the upper lower limit we will get what? A to the power 3 by 2. Okay, chaliye. Now I can take something common here. A power 3 by 2, a power 3 by 2 is there in both the terms, so I can take it common. So it will become what? 4 root a by 3. Okay, I'm taking common here as a power 3 by 2. What's left in this case? 2 power 3 by 2 minus nothing is left, so 1. Okay, alright, so now take this 4 root a by 3. Now what I have? A power 3 root 2 means what? A power 3 root 2 means what? Please understand. It means root a. If I take the power 1 by 2 part, root a to the power what? Power 3. Understand this? 2, 3 by 2. Same thing I can do over here also. I know that you know this, just giving explanation because of the variable. So I can write this as root 2 to the power 3 minus 1. Okay, now have a look. 4 root a by 3. Cube root of root a means what? Cube root of root a means a root a. It means a root a. Okay, same thing over here, 2 root 2 minus 1. Now bring this constant over here, you're going to get what? 4a square. How come, sir? Root 2a into root a is again a, and there is one more a here, so 4a square upon 3 was the variable. So this is my constant part outside, and this is the root in the bracket. This is my final answer. Okay, have I missed anything? I hope not. Okay, this is my final answer. Okay, if you are getting any answer other than this, solve and comment your answer. If you're getting any other answer other than this, solve this question and comment your answer. But I think the answer is right, 4a square upon 3, 2 root 2 minus 1. Okay, integration for this condition, please have a look. Okay, moving on. Question number 7. I hope this is visible, right? Okay. Find the area of the region bounded by the parabola y square equals to 4ax. It's x-axis. Okay, so axis means both axis and two ordinates, x5 and x8. Okay, same question. Okay, same question. X equals to 5 will be somewhere here, x equals to 5 is over here, and x equals to 8 will be somewhere over here. Okay, what's the curve? Curve is going to be same thing, y equals to what? 2 root a root x, because y square is 4ax, right? So y equals to 2 root a root x. Okay, do this and find this integration. This is my required reason, because they have mentioned this across the axis, so we have to take the limit with the x-axis. This is my area that we are looking to find. This is my a. My a will become what? My a will become integration from 5 to 8, 2 2 root a is the constant part, root x dx. Okay, solve this, you're going to get the answer to be option number A. Option number A. Please solve this. Okay, solve and give answer in comment section. Very, very simple, extremely simple, sir. Okay, similar question I've solved over here. Please have a look. Exact same question. Okay, just the limit is given in terms of a and 2a over here, and over here they have made it simpler by giving value 5 to 8. So 5 to 8. Okay, so have a look and solve this. Come on. Now question number 8. Area bounded by the curve y equals to x cube, the x-axis and the coordinates. What is it? The plane x, this and this. This and x equals to minus 2 and x equals to 1. Okay, so how will I solve this, sir? First of all, what most of the people, what they're going to do, they're going to solve it and they're going to get result either B or C. Okay, again mistake, big mistake. Reason why? Because if you remember the graph of y equals to x cube curve, okay, if you remember the curve of this graph, it looks like this. It has both negative and positive part. Okay, it has both negative and positive part. Okay, something like this, I'll remember. So what are they asking us? Okay, x equals to, boundaries you check here, minus 2 to 1, minus 2 to 1. Minus 2 is somewhere over here, minus 2, and 1 is somewhere over here. 1 is somewhere over here. Okay, so what is the area required to be found? See this. Okay, why this area only, sir? Because they have mentioned this, the x-axis. Okay, so I have to take the enclosing with what? With the x-axis only. As I've taken both the side x-axis. If they said y-axis, then I would have taken this area and this area. I meant this area and this area, but not required right now, so I'll not consider and erase that 2 lines. Chaliye, now moving on. So I will have to break this equation, this integration in 2 parts. From where to where? Minus 2 to 0 and 0 to 1. Why, sir? Because I have to take a modulus over here to make this also positive. Yes or no? Because I can't take the area to be negative. I don't have a negative area. Okay, so we must have to take the modulus to make it positive. So my integration, this whole thing, my area A will become what? So I'll write it as minus 2 to 1. Okay, minus 2 to 0, sorry, not 1. Minus 2 to 0. What is the function? X cube only. X cube only. Give me a second. X cube only with what? With dx but modulus. How come modulus? Because this is negative over here. Have a look. This is negative over here. Plus integration from where to where? From 0 to 1 and x cube dx. Okay. Alright. So if I solve this, I'm going to get what? I'm going to get x power 4 by 4. Okay. From where to where? Minus 2 to 0. And the modulus is gonna be there. From here also I'm gonna get what? X power 4 by 4. From where to where? From 0 to 1. This is my area A. Any doubt? I don't think there is a doubt over here. I hope this is simple and clear. Why are you doing this? Because this part, if you see the graph, is coming as negative. I can't have the area to be negative. For that reason, I have to take what? The modulus function. So I've taken the mod over here. It makes the result to be positive. So let's do this. So if I write like this over here, I'm going to write this area A as, have a look, I'll apply the limits. So 0 power 4 means what? Simply 0, sir, minus. Okay. What about lower limit? Minus 2 power 4 upon 4. Okay. Minus 2 power 4 is what? 16 by 4. Okay. Okay. Please have a look. Minus 2 power 4 will become what? Minus 2 into minus 2 into minus 2 into minus 2. So 4 times negative sign will come. So positive sign. 2 power 4 is 16. 4 is a constant, but the formula is what? Upper limit minus lower limit. So upper limit minus lower limit. Okay, that's how it is. Plus over here now, what is it? X power 4. So I put 1. So 1 power 4 will become what? 1 by 4, and 0 will be 0 only. So I get this as what? Simply 1 minus 0. Now have a look. What I get? This is simply 4. So I get minus 4 with the mod plus 1. How much is the answer? Sorry. Okay. Yeah, 1 by 4. Sorry, 1 by 4. Not 1. 1 by 4. How come, sir? 4 is there. No, that's why. Okay. 1 by 4. What is the answer? 4 plus 1 by 4. Take the LCM. 4, so this is 16 plus 1. What's the answer? So 17 by 4. Area, so square units. Okay. My final answer. This is the final answer. Okay. Have a look. Option number D. Option number D. Simple enough. Okay. Moving on. Question number 9. Question number 9. Find the area under the curve y equals to a square minus x square included between the x equals 0 and x equals to a. कर लीजिए. Let's integrate this. Okay. The graphical part I'll show you later because I will not discuss this today. This will come as a circle, right? This will come as a circle, I guess. Yeah. So we'll discuss that later. Right now, let's integrate this directly. Okay. How will this integrate? So if I do this, I can write this as, already they have given y value, no? Limits they have given. So I can write this area A to be what? From 0 to A. From 0 to A. This is a particular function, I hope you remember. This is a particular function, sir. Yes. What's the integration of this? So x by 2, same root will remain like this. Okay. Plus a square by 2. Since it is a square minus x square means sine inverse form will come. So sine inverse of x by a. Okay. Whole thing under limits like this. 0 to a. Okay. Check for the upper limit. Check for the upper limit. See if I put a, have a look. Over here, it will become what? A square minus a square will become what? 0. 0 into anything will be 0, sir. I'll repeat. Put upper limit a over here. A square minus a square will be 0. So 0 minus 0 into anything will be 0. Okay. Again with the upper limit only. A square by 2 is a constant, so it remains as it is. How much is this? Sine inverse of, put here x as a. A by a will become what? 1. Sine inverse of 1 is how much? Pi by 2. I'll repeat. I'm taking for upper limit a in place of x. Sine inverse of a by a will become what? 1. Will cancel each other. So sine inverse of 1 is how much? Pi by 2. So sine inverse of 1 as written as pi by 2. What about lower limit? Please check the lower limit now. If I put 0 over here, this is 0 times. Please check. If I put 0 over here and bring the lower limit now. 0 by 2, 0. This multiplied with anything will be 0 only, sir. Now putting 0 over here. Sine inverse of 0 by a, 0. Sine inverse of 0 is what? Again 0. So this whole thing will become 0 for the lower limit, and this will be what? A constant number. 0 into anything is again 0. What's my answer? Please check. So I get what? My result will be simply a equals to a square pi by 4 or pi a square by 4. Yes, pi a square by 4. Yeah, pi a square by 4. Option number C. Correct? No problem there, right? Pi times a square by 2 into 2 is, which is 4. So option number C is correct answer. Simple question, very very simple. Okay, moving on. Next question. The area of the region bounded by the curve y, okay, the curve y equals to x square plus x, the x-axis and the lines x plus x equal to 2 and x equals to 5. This is a very good question. Okay, if you solve this, even if you solve this directly, you're gonna get the answer. I think your answer should come like this. I don't know. We'll see either C or D. I think C should come. C should be the answer. But if you do it directly, you're gonna get the answer right. Okay, you don't have to draw the graph. You're gonna get the answer right. But why I'm drawing the graph right now for this question? Because if they change the boundary condition, if they change the boundary condition from 2 to 5 to some other value, then you're gonna get, make a big mistake and lose marks over here. Okay, chaliye. So let's see, x square plus x. Okay, so what type of graph is this? Can you see the graph? It's quadratic, so parabola. Okay, what type of parabola? Concave up, sir. Okay, and positive, what is the constant here? 1 times of x square, so positive, so no problem there also. 1 x square means concave up. Okay, square is the power 2 is on the x, so symmetric about x axis. Chaliye, means parabola is like that. So trend we know the graph will come something like this, but where, we'll see. So we got to know the graph, what type of graph is this. Okay, but what are the critical points where it is, we'll see from our observation. Okay, so x square plus x is a graph which will be a parabola, will come concave up. This much is enough, this much information we know as of now. Now check here, a number is present here, same number square is present here, so x square plus x. So can you say that this number is y is always positive? So even if you take a negative number, take a square of that, will become very big number, again positive only. Let's say I take minus 5, square of this is how much? Plus 25. So always there will be positive. Can you say this is always positive, the y is always positive for this function? No sir, not always positive, because if you take from value minus 1 to 0, let's take minus 0.5, square it up, what are you going to get? Square of this will be 0.25, right? 5 square is 25, but you have to take the decimal place also twice, so it will become 0.25. Now what is x value? Simply same number. How much is that? 0.25 minus 0.5. How much the answer is? Sir, negative minus 0.25. So basically I'm trying to explain you over here, I'm trying to make a point over here that in this range minus 1 to 0, what will happen? The graph will be negative. The function of the value of the y will be negative. Okay, so if I draw the graph like this, will you accept it? Again I said does not matter in this case, sir, because the limit is positive. Please check here, if you are smart enough, if you can figure it out. 2 to 5, after knowing this, no, you don't have to draw the graph directly. So 2 to 5 is all positive. Please sir, check. 2 square is 4 plus 1 5, sir, positive. 5 also positive, sir. So 2 to 5, the graph is always positive, sir. In this case I don't have to draw and see the graph, I can directly integrate this, I can directly to find answer. No, what you can do is directly write this, a equals to integration from where to where? 2 to 5, the function you write x square plus x dx. Solve this, you're going to get the answer. See, directly, very simple, very simple. Okay, but if the limit is changed, then the problem will occur. Okay, if I write like this, let's say I write minus 6 to 5, then what? You know, to break minus 6 to minus 1 to 0, and then 0 to 5. Understand this. If I write the limit from minus 6 to, let's say, 5, then you can't take the integration directly. You have to do what? Minus 6 to minus 1 you have to do. Then you have to do again integration from minus 1 to 0, but with the mod you have to do the integral, and then you have to take again other limit 0 to 5. That's why I am pointing this question over here. So whenever you see this kind of question, try to, if not drawing the graph, try to conclude with, knowing where the negative part occurs. Is the graph having a negative value or not? Okay, whenever you find negative value, apply the mod. Otherwise what's going to happen? No, you're going to get a wrong result, because if you don't apply the mod, no, the value will be negative and the result will be including the negative value. Instead of adding, you're going to subtract it. Okay, so make sure that you avoid it. And how can you do that? By knowing the range where, knowing the interval where the graph is negative. So you got to know the graph is negative from where to where? Minus 1 to 0, sir. All right, let's see, minus 1 to 0, sir. Okay, so upper concave of parabola, right? So we'll go from this point, yes or no? Put x as 0, 0 plus 0, so 0 only, no? X is 0 means 0 square is 0 plus 0, so it will go from origin, no problem. Okay, so this is my parabola. Okay, what is this point? Minus 1, this is 0. Doesn't matter in this case, as I said already, because our boundary is what? From here to here. This our boundary is, okay, x equal to 2 line is this, okay, and x equals to 5 line is this, okay, and they said what? X axis also. So this is my region, this is my shaded region. This is my shaded region. Okay, so if you check here, same thing I've written over here. This curve is y equals to x square plus x, so over here plus dx from 2 to 5. If you integrate, what you're going to get, please check. So I'll get x cube by 3 plus x square by 2 from where to where? 2 to 5. Okay, 2 to 5. This is my area. So let me just simplify this. I write this thing again. So x cube by 3 plus x square by 2 from 2 to 5. Let's apply the upper limit first. So 5 cube means 125 by 3. Okay. 5 square means 25 by 2. Do for 2. So minus. We're doing for lower limit. So minus will come. 2 cube means 8 by 3. And 2 square means what? 4 by 2. 2 is there. This is my A. Change the sign please. 125 by 3 plus 25 by 2 minus 8 by 3 and minus 2. What's the LCM? Offered 3, 2, 3, 1, so simply 6. So take the LCM as 6. 3 to the 6 means I have to do for the equivalent fraction I have to multiply 2 in the numerator as well. 3 to the 6. So I have to do the equivalent fraction. So 250 will come. Over here 2 3 the 6 means 75 will come. Minus 3 to the 6 means 16 will come I think. Right? 3 to the 6 means 16. And minus 1 6 means 12 will come, right? 12. Okay, have a look. 250 plus 75 minus how much is this bacha? Please check. This is 28, right? 28 by 6. 250 plus how much is this? 75 minus 28 is how much? I think 47. Because if it was 30 it was then it will be 45. 2 less, so 2 more over here become what? 47. If you're not sure, do the subtraction. 75 minus 28 is 47. Add it. 297 by 6. 297 by 6. This is my area. What is my area? 297 by 6. Please have a look. Again, what is the unit? We don't know. Write it as square units. Yeah. Option number C. Okay. I hope this is visible. Yes. Okay. That's it for today, bacha. I hope you understood this session. Okay. I hope everything was very clear. Very simple it was. I don't think there was any part which was very challenging. Good session. Okay. So that's it for today's session. Please keep working hard and keep coming up with more and more doubts if you have any. I'll try to entertain all of it. So I don't want your energy level to go down at the last moment. So maintain the flow because it's very difficult to make good habits and very easy to lose them. Okay, so keep working hard and keep solving more and more problems because your exam is about competitive examinations is all about questions. So solve as many questions as possible, and if you have a doubt, if you have a query, get in touch. Okay, so with this I'd like to end the session. Take care. Bye bye.